Yes, hello everyone. Welcome to the LLM show. I'm your host Shamaine, and Ruin is here with me as well today. So, in previous episodes, we were talking about parameter efficient fine tuning, all these open source LLM models. But in today's episode, we want to talk about what are the real world applications that we really can build with these open source LLM models. So, we thought of talking about a paper that explains about how to use these large language models in order to create a conversational recommendation system. So yeah, Ravindu, over to you. So what do you think of using
Oh,
LLM in
yep,
different applications? So Ravindu, I have a question. So now we have these open source LLM models,
yep,
and we can use them to create different applications, right?
yep.
So what do you think of these kind of applications? Like, can they truly create a difference in the software domain? So what do you think of these
I guess there's
applications?
different levels of customization you can do on top of LLMs. Like the easiest custom solution is to do retrieval augmentation, and then you can go down the path of doing more and more complicated things. Like you can get it to do. It depends on how you use it, I guess, but like you can get it to pass JSON, like output strictly JSON for different applications. But like if it's general conversation stuff, it's quite easy to adapt what's out there. But like you can use it much more creatively. I don't have ideas off the top of my head, but there's a bunch of ways that the language model can be like fine-tuned with LoRa and things to do stuff that is more interesting, I think. But that is something we need to explore.
Yeah,
Like the
yeah,
recommendation stuff, I guess, on this
yeah,
paper, which I
yeah,
have
yeah.
not read.
I kind of like the idea. Like we kind of can use these LLM models for a lot of creative stuff. Let's say in order to autocomplete your email or kind of check grammar for your research paper or create content. That's kind of pretty, I would say, pretty straightforward.
Yeah.
Like,
You can just use
but
OpenAI's API, right?
yes, exactly. Earlier we were talking about using using LLM models to kind of uh, create a structured data set from some sort of unstructured data.
Yeah.
So you were talking about this concept of hallucination, right? That's
Yeah.
a major problem in LLM models because it's kind of a fundamental thing as well. So I would say to still like I would say in order for us to use an LLM for a task.
Understand the good things and the bad things that it can like, what the weaknesses and the strengths of it, I guess.
Yeah,
But
true. Yes, so that's true. Like, so we need to understand where we can
where
use
they
these kind of LLM models, and will they actually make a big difference? Because there might be so many factors, like theoretical things, like the hallucinations will be always there, and because you need to trust your output, right? Sometimes, so for
Mm.
some like, but again, don't get me wrong. Like, for example, if you wanna like autocomplete your email, or if you want to kind of autocomplete your abstract of a research article, still you can use OpenAI because the sensitivity of that output is not that high, I would say.
Mm.
It's all right. You can
Yeah.
kind of make some sort of an error still. um,
Yeah.
there's a margin for error, right? Like
Yeah.
margin for error is kind of okayish, I would say. But
Yeah, I mean,
again,
you shouldn't use it to like look up previous cases, like if you're a lawyer, because it'll just make up those cases, right? Like things like that, you have to be quite careful about. Like you
yeah,
need to
yeah,
understand the limitations because that was one of the lawsuits recently, right? Not
yeah,
recently.
exactly. Because yeah, you first need to understand LLM models have a parametric memory, and if you wanna like extend it, then you need to use something like retrieval augmentation. So you actually can do it, but yeah, things like
I mean, if you ask
maybe,
ChatGPT, it'll give you a bunch
yeah,
of
exactly. Like sometimes when you ask, like sometimes it happens, right? When you ask a question and then ChatGPT will give an answer, and then you ask, can you kind of show me some references, and ChatGPT sometimes can kind of create things of its own, right? That's the
Yeah.
best case of hallucination. But like again going there, like let's say, can ChatGPT, my question is for you, can ChatGPT replace software engineers or coders? What do you think?
It'll make them much more efficient than they are right now. So there's an argument, there's two ways it can go, right? Like you can, because right now there's a software engineers are in demand. So like companies can either produce much more software or they can reduce the number of people they hire. And so basically, if they reduce the number of people they hire, that means there'll be jobs that get lost. But if they decide to do more things with in the same with the same amount of hiring, then I feel like they might go down that path more often than not. Like they'll try to do more things because we haven't run out of things to do with software engineers. So
Yeah, exactly. It will always make life easier, but I would say kind of, okay, you give a prompt and it will create a code and we can
yeah,
like just deploy it. I would say it is still kind of few years ahead, like like a self-driving car, fully
yeah,
automation.
you'll still need
Yeah,
software engineers, but
like
they'll just be more efficient.
yeah, I like the concept of human-centric artificial intelligence, like human in the loop, like yeah. So, but again, when we are talking good things about LLMs, the 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 main the main highlight is these language models have seen a lot of text data,
Yeah.
trillions of tokens and billions of parameters, and they have like kind of a huge knowledge to understand natural language. That's a big thing. So basically we can use LLM models as an interface to um, like simplify different problems and then
Mm-hmm.
create solutions on top of it, like
Mm-hmm.
language as an interface. So maybe in future text is all you need, because my point is language is such a fundamental thing when it comes to human communication. Like if we want to learn new things, the first thing we would try to do is either to like read, listen, or kind of try to understand, right, through some sort of a language, rather than kind of
I
try
mean,
trying
yeah,
our own things.
I guess most of knowledge, human knowledge, is stored in language, but like I don't think you can just ignore visual though, because that does have a quite a big
True.
set of information that you can't really get straight just from
Yeah.
straight up language.
Yeah. Sometimes seeing a figure would help you to understand a concept better than just looking at the text of it, right? So
Yeah.
yeah, I
I think
completely
I
agree.
think the yeah, I think the language models will be like more or less the central part of a system, but like like even with GPT-4 you see like the multimodal stuff.
Yes. That's what I also think. Like when it comes to LLMs, so we are seeing a lot of multimodal language models, a lot of theories that show fine-tuning language models can give better results, and also we kind of can fine-tune them efficiently without losing much performance, and also we don't need large amount of downstreaming data for that. Having a good refined data set is good enough to kind of create a huge difference. So then the big question is, what are the applications? Then there are so many applications we are seeing, but then I saw this paper from Google. It's more of a proof of concept paper they are kind of presenting. So this is the idea of how to use a large language model to create some kind of a conversational recommendation system. um, I really liked it because, to be honest, when it comes to artificial intelligence, recommendation systems control everything, because it
Mhm.
is where most of these companies make money.
Yeah.
Meta, TikTok, Google, Amazon, like they sell ads, they show products, and that's for that you need to have a recommendation system. And we deal with recommendation systems a lot, like let's say Netflix, YouTube, Spotify, your news feed, your
Yeah.
Instagram feed,
Even
everything
before
is a
AI was
recommendation
popular,
system.
like even
Exactly.
like 10, 20, 10, 15 years ago, maybe, like
Yeah,
recommendation systems were
like
still like,
I mean, I really like this paper, and it's kind of it's kind of highlighting these are the areas you kind of need to watch out if you want to apply or if you want to create your LLM based recommendation system. And yeah, that's pretty much it. So let's go to the paper, and I'll quickly share my screen. Okay, the topic is leveraging large language models in conversational recommender systems. And yeah, this is pretty much from Google Research. And just let's go to the abstract first. So I highlighted some of the key concepts. Um, so they first talk about like the recommendation systems and LLMs in general, how good they are understanding language and all. And then they talk about what is a conversational recommendation system, or they call like CRS. So conversational recommendation system is a recommendation system that can have some sort of conversation, some sort of a conversation with the user, that's pretty much what a conversation recommender system is. So yeah, like again, like I think
so
this
to
is
give an
yeah.
example, it'll be like, what movie should I watch type thing, right? And I have a conversation with you, and then through that
Yes.
conversation, we decide what movie I should watch.
Yes, exactly. So you ask what movie I should watch, and then the recommendation system will come up with some sort of an answer, like saying, "What do you like? What do you usually like?" And also keep in mind, we can have some kind of prior information about that user as well. So maybe we don't even need to ask, "Oh, you like this stuff?" Recommendation system will directly come with an answer, and the user can always
Give feedback.
kind of yeah give feedback. So it's pretty much like ChatGPT. And I really think these kind of recommendation systems are the future, because imagine like ChatGPT changed the concept of web search, right, a lot. Because we always like to have conversations, we always like to kind of interact with some kind of a system in a conversational manner. So that's, I would say, that's a fundamental thing. And when we also think about human computer interaction, I would say this is very seamless, you know so yeah, that's pretty much the abstract says, like they're saying, in order to have a conversation recommendation system, the first thing is there should be an interface that can properly understand the user's intents and all, so of course LLMs are there, and why not we try it. Yeah, shall we go to the introduction?
Yeah.
They say like how we traditionally create recommendation systems. So right now what happens is when you log into your Netflix, you will see some kind of movies, right?
Mm.
So those movies have been already picked by the Netflix recommendation algorithm, and you just see them once you log into it, and they might be refreshing it now and then. That's how it works, and there's no real interaction. There's not much of a feedback you can give, right? That's how current recommendation systems work. And
The
then they
feedback
say
will be slower. I mean, you can
yes.
put thumbs up and thumbs down, but it'll take a while.
Yeah, exactly. So yes, so you can, yeah, you can actually you can give some kind of an implicit feedback. I know now in Facebook you can kind of say, I don't like to see this, or I like to see this kind of post more often. So then they will use that implicit feedback and they will train again. So basically the
Yeah, but that doesn't
or
help me pick a movie.
no, no. Yeah,
Yeah,
yeah. It does not. I mean, maybe in future, but
yeah,
but
yeah,
you can't get that direct effect.
yeah,
It's
yeah.
not that prompt. So then they tell like then authors highlight. Okay, there are a lot of prior work on recommendation systems, and especially they talk about collaborative filtering stuff. So we all know collaborative filtering algorithms. So what happens is
I
you
don't think
collect a
everybody knows, but not the
yeah
recent people.
yeah. So collaborative filtering algorithms. I'm not going to talk much about collaborative filtering algorithms, but they are like the fundamental machine learning algorithms for recommendation systems. So what happens is you basically collect a huge item and user interaction metrics, right? So then what you do is you kind of decompose each user and each item into a vector and kind of you optimize a system. So
Because I think that's
like
where Netflix started with recommendations, right? In 2012, they were doing matrix
Netflix.
factorization stuff.
Yes, exactly. So that's
Yeah,
what
so the
uh,
intuition is user three watches looks like superhero movies. So that means if user one has watched a few superhero movies and seem to like superhero movies, then you're more likely to recommend a superhero movie.
yes, exactly. So um so then what these authors mention here is like although these embedding based recommendation systems are there, they also have a lot of negative effects. Some of such effects are like surfacing clickbait, because you kind of get optimized with this implicit feedback, right? Like just clicks or something, your entire system get optimized with those kind of stuff. And also they say propagating societal biases and polarization. You will always kind of get to see what other users might see, like because the idea is these these recommendation systems like collaborative filtering, they
The whole point is to generalize to people that are similar.
yes, exactly. And also they get developed with this implicit feedback. So the thing is you can't change much, right? That's the idea. You can't change much because all you do is like because your algorithm kind of try to capture similar users and similar items. That's what it does, right? Pretty much. The introduction, what they say is, but having conversational recommendation systems can kind of answer some of these questions, which is true, right? Because now user is kind of in the middle, like user directly can interact with the system, and then the model kind of can predict what is good for the user, so yeah. So basically then again they explain what is a conversation recommendation system, which we already explained just before. And yeah, so this is pretty much it. And then then they say yeah, then they say like it's having a conversation recommendation system not only can recommend good items but also can explain, because it also can explain the user why I am kind of showing this product to you. It's more like what they say is like a byproduct, and it's like an intuitive natural language expression as a byproduct. So yeah, so those are like pretty much the introduction. It's very interesting. So then they explain about some of their key contributions. So one such contribution is a dialogue management module that reframes natural language generation, preference, understanding, context tracking, and calls a recommendation engine as a unified language modeling task performed by a single LLM. So the idea is like they have some sort of an interface that uses an LLM which can understand users' intent and somehow call a recommendation engine and then recommend products to a user. So do you get this part?
Yeah.
Yeah. So So this is more like the first layer of the system, right? You need to have a system that can understand users intent and the idea or whatever it is, right? Then of course we need a retrieval element, because unlike a normal LLM application, here our model needs to work with some kind of an external memory, right? Because we just discussed LLMs are like parametric models, so their entire knowledge is inside parameters. But when it comes to this kind of a model, your LLM should interact with your your LLM should interact with some kind of a custom knowledge base. In this specific scenario, custom knowledge base is all about different users, different items, because no point of training an LLM with all the user features and item features, because we need to change both user and item catalogs, right?
Yeah.
So
Yeah.
so retrieval part plays a big role. So uh, how I understood this is basically you say something to the LLM, right? Then LLM kind of try to understand what you are and what you really like, and then create an embedding representation of you, right? And then somehow call uh, let's say a vector similarity search, like approximate nearest neighbor thing, and then find what are the most similar product for you. I mean, this is like the simple more this is like the simplest picture you kind of can create out of this thing. What do you say?
Yeah.
Yeah. Then they also have this thing called joint ranking explanation. So the idea is once you generate stuff, the idea is once you retrieve items, right? Then usually we can retrieve top 100, right? We kind of
Yeah.
show this is what our system shows, like these are the top 100 items for you. And then rather than using all these top 100, you kind of can now use those top 100 items with their metadata as a prompt to your language model, and kind of further reduce the number of possible items, and also can generate bit of explanation, for for your prediction. I think that's what this
Yeah.
joint ranking explanation does, which is pretty cool, right?
So what is the
Then
joint ranking again? Because I see on the right you can ask why this video was chosen, but then I understand the retrieval part as well. Well, like because you retrieve the most relevant stuff to the conversation or whatever. But what does joint ranking mean?
so joint ranking explanation, it means like because you retrieve, right? You can retrieve
Yeah.
top 100 items or something, and
Yeah.
then what you can do is you can use the metadata of those top 100 items
Mm-hmm.
and create a query, and then use an LLM to kind of explain about your prediction, and also users can further ask questions, because now
So in
now
this
your
case,
LL
again, for the YouTube example or the Netflix example, what would the metadata and query be?
which one? This YouTube one?
Yeah,
So I
like
think
for
the
joint ranking, whatever.
so not
So
you are not
each
talking
video,
about this image, right?
it doesn't matter. Maybe that image. So like the metadata of that image will be the video title and maybe
Yes,
what's in the
exactly.
thumbnail or
Yeah,
whatever it is.
yeah,
It's the first one is History Channel. Here's how national parks something something,
yeah.
and then you feed that into an LLM together with something else, and then what do you
With
tell
your
the LLM
past
to do?
conversation or something like that. So the idea is you recommend items while having discussion as well,
Yeah,
so it's not like you won't uh, it's not like, okay, conversation is done, here are your items. It's not like that, because that's the whole point of
or
having
you
a
refine.
conversational recommendation.
So you get
Yes.
100 items, then you refine it down to like 20 or
Yes,
something.
exactly. I think this is the part I really liked it. Well, I really like, because in the like this part they say this retrieval part, it's not easy to do end to end, and I also think it's
Mhm.
it's hard, right? Like
We
to
we
train or
we did
something.
that,
But
right? You
sorry,
did it mostly.
no, okay, that
We did it in RAG, right?
you mean like okay, in retrieval augmentation? Yes, yes, yeah, exactly. That's a so this part is retrieval, yeah. So in RAG, we did this retrieval augmentation end-to-end training. I mean, this is like a really time-consuming thing, and also pretty costly. I don't think you actually need to train this kind of a system end-to-end. Ask a question, and there's this end-to-end retrieval augmentation part, because my point is um, these language models are really good when it comes to understand the context, right? That's the whole point of having large language models. But yeah, let's see what this paper says. And yeah, finally they say you don't have a lot of conversational data, right, to train a system. And for that, they have come up with a simulator to generate more data. So they mainly use this data set to kind of do this joint ranking and they to improve this joint ranking and explanation model. Yeah.
Mm.
So moving on. Um, so like this is a good example. Like rec LLM possesses many conversational capabilities, such as ability to retain context through a session, handle topic shifts, and reference items from recommendation slates. Yeah. So yeah. So basically, like, hi there, I am your video recommendation assistant. What do you like to watch? So this is what you would see once in future when you uh, log into YouTube, and then show me some match highlights. And what what this shows is like model knows, like, okay, I'm going to show some tennis highlight to this, or like not show, like I'm going to start the conversation with this word tennis, because we always can keep some kind of a context about the user, right?
Mm.
Because that's a cool thing. That means when it when a new user come, we always like kind of use his or her past interactions. So that's the power of language, so yeah. So
But I feel
that's
like in the future there'll be better ways of embedding that information somehow that
yeah,
is not
right,
necessarily
yeah, right
visual.
now they actually use a lot of text,
Yeah.
like rather than trying to go with super complex embedding mechanisms in the paper. So then yeah, this is another example. I would say, like, they highlight different capabilities of their model, remembering user preference over conversations and applying to new conversations, handling change in the topic of conversation, because that's like when you have text you can do a lot of stuff. So I would say one a main thing they want to highlight is you actually want to fine tune an LLM in a way it can handle these type of conversations. Do
Mm.
you understand? Like, because these are like e-commerce related conversations, more like, yeah, they have a commercial point, because in the paper they also mention we also don't want to just have like random conversations with the user, because our entire point of this system is to make sure user will purchase or user will get what he or she wants, so
Mhm.
that's why I think they want data, and they want to fine tune this. Yeah. So then refining recommendation to a narrower topic. So basically the idea is, let's say after this tennis thing, like now you say, of course, sorry, show me some match highlights. Of course, here are some highlights of exciting tennis matches. So now how I understood is the system is so fast, and you kind of can encode this context somehow, and then retrieve some of the items. Here the items are actually videos, and then user can keep having the conversation. So yeah, that's pretty much it. And then so let's go to the system overview. So in this section we take a closer look at key system components of Rec LLM. In particular, we focus on dialogue management, retrieval, ranking, explanations, and incorporation of natural language user profiles. So we already talked about dialogue management, right? That's pretty much like question answering, keeping the dialogue with the user, pretty much like ChatGPT. And retrieval part is mainly that vector similarity search, or like somehow retrieving items given an user embedding, right? And then ranking is pretty much like show okay, now you have retrieved stuff, and then kind of reduce the number of possible outcomes. How can I say, like
Yep.
clean up. It's like a cleanup process, right? You rank, so this is
Cleaning the
best and this,
retrieval. Yeah.
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 And then you can add some explanations, because you can use that metadata of these retrieved items, and kind of let the LLM to generate different explanations. And yeah, incorporation of natural language user profile. This is real nice. This is like you kind of can represent an user with whatever he or she has discussed, or like
Yeah.
watched, purchased in language, so this
That will still
figure,
have the cold start problem, right?
not
Because the
really
user
real.
profile, like how do they know it's a football fan at the beginning?
Yeah, I mean, definitely, like I would say uh cold start problem. Yeah, like if there's a new user, of course
Yep.
it's like it's a fundamental cold start problem. But how I see the cold start problem is like when the company can't recommend a new product to existing users. That's a big thing,
When the
because
product is okay.
yeah, when the product is new, because
But it's also a challenge when the user is new. Because I mean, you
yeah,
can say something general like I am a user from New Zealand or something. I
yeah,
guess you can
yeah.
start with.
I mean right now
That
what
is
happens
probably what
is,
YouTube does.
yes, right now what happens is, if in Netflix you actually need to pick some of the
Yeah,
movies,
yeah,
right? They ask you
yeah,
to pick. But
yeah,
in maybe in dialogue management, this kind of a thing, since you are trying to represent a user with natural language, the good thing is
yeah.
like you can ask the user to write something about you, write what you like. It's more like, for me, it's more intuitive rather
Wait, so
than just
in this case, it's not an output of the LLM. Like user profile is not generated by the LLM.
no,
It's
no, no.
okay,
So yeah, so basically,
provided
yeah.
by user,
So this is
maybe.
like the system,
Yeah,
user profile, item summary, dialogue. So basically, I would say all these three components can represent a user.
hmm A
So,
context. I mean, yeah, the state of the conversation.
yes, yes. So user profile is like, I'm a football fan, funny animal videos, laughing. So this is like the history, right? So again, this again highlights the importance of the retrieval part, not retrieving these items, but you need retrieval engines plugged into LLMs, right? Because this kind of information will be outside of your LLM. So
Mm.
basically, you need to call them and kind of use.
What I don't understand is why the instruction and the context tracking is out. It looks like an output.
Yeah. So how? Yeah.
Because
How?
it's usually the system prompt or whatever in ChatGPT, right? That is,
Mm-hmm.
like, the user is looking for recommendations. Please respond naturally to the user referencing the item summary. That sounds like an
Mm-hmm.
input, not an output.
No, no, no. How I think is like, still this is the dialogue management model, and
Mm,
this doesn't have the recommendation component yet, you know.
mhm,
So that's what they say in the introduction. They are like, okay, we have used a separate dialogue management model and
mm,
separate recommendation or like retrieval model. So the idea is you input something, and this is more like, this is fine tuned in a way that it will generate something like that. The user is looking for a recommendation instruction, respond naturally to the user reference in the item summary, right? So
mhm.
do you understand? So your LLM can understand this query, and you can talking keep talking to the user. And if maybe, if like maybe this could go for a few turns, right? Maybe
Yeah.
in a single turn LLM thinks, okay, now I think we should able to recommend something, we have enough context. So basically, uh, this is like the response, you know.
Mm.
Sure, here are some funny videos, including some funny animal videos. And so basically this part
So this is
also being
for
created.
one. Okay, so this is one item, right?
Yes, exactly. So what you don't see here is like actually the like how they retrieve an item. So basically the idea is the retrieval part also happens like, maybe they can use some of the context from here and some of the understanding that is happening inside the LLM, plus kind of combine it and then create this user preference vector or whatever, you know. User profile, item summary, dialogue.
So yeah, user profile is you, Shaman, looking for
Mm-hmm.
a movie. Item summary is probably a funny animal video, laughing football game moments, and
Mm-hmm.
then dialogue is like your previous conversation history.
Mm-hmm.
Like that's what I understand from that. And then you feed that into the LLM, and it gives an output that says, I don't know what context tracking is, but the user is still looking for recommendations. I don't know.
Yeah,
It'll
let's
like,
yeah,
and the instructions can be respond or ask a clarifying question or something.
this is description, right? A unified LLM dialogue management module. An LLM takes an input, the full session context, and outputs a session sequence of messages ending in the terminal output that triggers a system action, such as response to the user. So
Hmm.
according to that, how I think is this item summaries, maybe a summary of an item that the user has already watched or something, you know. It
Hmm.
comes from the profile, like something related to the user. That's how I thought, like, because he's the one that would trigger, okay, I'm ready, you should respond response to the user, you know. So we can quickly go through. So the idea is, so according to that, CRS acting as the interface between the user and the rest of the system. So it is responsible for guiding the user through multi-turn exploration of recommendation corpus and generating sensible, useful, and grounded responses at each turn. In the process, it must either implicitly or explicitly perform context tracking to extract useful representations of user preference and intents. This information can be used to inform the dialogue policy, also as the basis for outputting API calls to initiate system actions by sending a search query to recommendation engine backend. So right now what they say is, so basically it's not, so you can't think of this as a single thing, you know. It's like, this is where the conversation will happen, you know. For that, you will use a lot of metadata, a lot of history, previous conversation, because and then and then it can also kind of output response. It knows when to take an action. So when it triggers the action, it kind of can this is an example, can send a search query to a recommendation engine backend. So this would be some kind of a search query, maybe. No, this user is looking for recommendations. Instruction respond naturally to use. I would say this is more. So this is more like the instruction fine tuning, but yeah. So I think we will get the idea. But do you get
Yeah.
the usual idea?
Yeah, we'll go through a bit more. Maybe I'll understand it.
Yeah. See
What
the
the other
section.
steps.
Yeah. From an end-to-end point of view, given context information, dialogue history, a user profile, item summaries, the goal of the dialogue manager is to generate system actions to take, as well as an appropriate system utterance. So it's not just single item, some, because we can always keep what user has clicked before, dialogue history, user profile. You use all these things, and these systems, the main idea of this system is to kind of understand what this user is all about.
Yeah, and then decide what action to take. Yes.
Yes.
And the actions can be control. No, not control. Okay.
Yeah. So then, so what they're saying is, so yeah, here there's not much. They're saying okay, this should be just an open-ended dialogue system, because the idea is we should make sure we will somehow give a user what he or she needs, as quick as possible. So system must respond to user requests, and also at times actively steer the conversation in a specific direction, So this part might be a lacking thing if you don't have your own data set or something. I don't know, because if you use just a normal language model, large language model, these properties might not be there.
Yeah, but it said the goal. I mean, the context tracking will keep track of this user is looking for recommendations, so try to stay within.
Yeah. I mean, yes, true. Because we can always append the history, right?
Yeah, and you can basically instruct it to stay within the topic.
Yeah. I think this
or
is
even just
one such.
Explicitly steer the conversation in that direction.
This is one such instruction, right?
Yeah.
The user is looking for recommendations. Respond naturally to the user reference in item summary.
Yeah.
So yeah, I don't know why they have put this is the output from the I understand now why this is output, because this could go multiple utterances.
No, I think there's multiple instruction. One instruction is to respond to the user. The other instruction might be to, I don't know, look up another or ask a clarifying question or something.
Yeah. So basically, okay, I kind of get it. Basically what happens is you generate a lot of stuff, right? And but you only show the user this terminal output, but these stuff still you can use it for the next turn, Yeah, I mean because I've seen especially with some pre-trained especially with some fine-tuned Falcon models, there are different ways of instruction tuning. So some of these models can output the answer and some kind of description or kind of a summary of the question, so they do this stuff. So yeah, I think it's clear now, right? So the idea of that system is still to keep the conversation and somehow get the much more context as possible, so then the ambiguity is, so task oriented dialogue, there's no clear cut measure of success for a CRS dialogue manager, although the system should try to ensure that the conversation does not get too far off the track of the core recommendation task. Yeah, it's again pretty much like the control. And these are like fundamental questions like grounding. One of the main challenges of CRS Dialog Manager is to faithfully ground its response to the user in the recommendation corpus. After returning a slate of recommendations, the system should be able to refer to the items uh, in a relevant and factually correct way. Because yeah, because now they say like they also have this joint ranking explanation system, so they don't want to create any hallucinations or like add different like explanation for their products and all. That's what I think, because it could be a huge problem, right? Yeah, so I'm moving on. Is it all clear for now?
Yeah. Yeah.
um
This part is fine at the
yeah,
moment.
then some of the recent CRS language models are turned on end-to-end directly to imitate dialogue collection from crowdsourced workers, discarding any notions of dialogue slate or internal structure. So they're saying like there are some prior work where you try to do this end-to-end, but what they say is rec LLM, we employ single unified LLM to execute dialogue management purely in terms of language modeling. I really like this. So you kind of have this system to understand language. It is what we just talked right in the beginning, using LLMs to as LLMs as an interface to solve problems. And at each turn, LLM takes as input the prior conversation context along with additional information like textual representations of recommendation slates and user profiles that are potentially injected from external source. So again, you need to, this is like how you kind of modify the prompt during a conversation. Like the end-to-end approach mentioned above, one of the distinguishing feature of this architecture is that there are no longer exist a hard-coded policy graph with fixed dialogue states. That means previous conversational conversation recommendation systems had like hard-coded like states, like maybe like if you do this, this is now you need to show this. Like, is it like, is it, am I understanding it correctly?
Maybe, I don't know.
Yeah. So yeah, instead of giving a system instead on a given system turn, the LLM generates a sequence of natural so this is what we are talking. Instead of given a system turn, LLM generates a sequence of natural language output that encapsulate all context tracking, intermediate reasoning, and natural language generation, and API calls to the rest of the system. So it is hard-coded that the certain string patterns in output from the dialog manager triggers system actions. So do you understand how they call, right? This is now, this is the right time. I need to create an embedding out of, or like I need to create a query out of this context and send it to my retrieval engine. So they are like, will, so response, yes. So you can see like response part, if the response part is there, like it will always, so it will also like parallelly call the recommendation API and get those items and show. So response message will cause message to be shown as a user facing response, and request will cause query to be sent to the recommendation engine backend to retrieve slate recommendations. Slate means like already created, right? Like they are already been they are like encoded or something, they have their states. Yeah, so now it's pretty clear, right? They are this part is pretty clear, right? So
So instead of response, it could be a request, or both a request and a response.
Yes, so yes, I would say like probably probably like it should have both. First it should be request, and the response, right? Response because probably
Response is the response to the user, it looks like, but
yeah, that's what they say. Response is
yeah,
the,
yeah,
so
yeah,
when they say, when they say, see, okay, now we have this output we have this word in the output text response.
yeah, yeah,
They will, okay, we are going to show this. So if the output has the request, we will call the
yeah,
recommendation engine and
yeah.
get it.
But if the LLM may decide to not have a request even and just ask a clarifying question, right?
Yes,
And you
yes,
don't
that,
make
yes.
request.
Now you're getting it. So the idea is, this is not just creating an embedding out of an LLM, but more like we kind of ask LLM to kind of control the conversation, you know?
Mhm.
Yeah. So yeah, that's pretty much it. So that's pretty much it. And then we go to this next section, recommendations and refinement. So once triggered by the dialog management module, it
Yeah,
is the responsibility of the recommendation module to return a slate of high quality, relevant, and diverse recommendations that will be shown to the user, right?
yeah,
This can either be an initial recommendation slate or a refinement of an earlier slate from the session based on feedback from the user.
yeah,
Do you get that? Like,
yeah, yeah.
so this
So you feed in either you feed in the previous recommendation, and you when you do the similarity matching, then you eat the. I don't think they do the similarity matching across the whole database, right? They probably do some sort of
yeah, they are not even
filtering.
like, because their recommendation engine is completely separated. So
Yeah, but you like once you get 100 recommendations, then they might do similarity matching on those 100, and you feed the conversation as input, and each of the 100 items, and then you compute some similarity,
mm-hmm, mm-hmm.
and then the most similar ones.
Yes.
I don't know
So
thresholding. I don't know.
yeah, I think like that's what they say, like pretty much. So I would say like, or maybe what they say here is, um so so now you kind of you kind of find this query or whatever it is, right? And
Mhm.
then you call this recommendation system. The recommendation system already has its own embeddings, you know. You kind
Mhm.
of show those recommendations. But what they're saying is, sometimes you actually can refine your recommendation state as well, items and all, like based on the feedback, you know, from
Mhm.
the user. So basically they are like, they can change the recommendation embeddings as well, like periodically or session based. I would say that's what they say here, because no point of showing all the recommendations, right?
Mhm.
It's, I think they are talking about these embeddings and the recommendation system update, you know, that retrieval part update. See, a traditional recommender system chooses items by inferring preferences of the user from some type of user profile or dense representation built from historical data, possibly taking into account other contextual factors like
Yeah.
location or time. In the search system, the user can supplement these implicit signals with explicit intents, usually through a simple static query. Yeah. So, mm, so basically, what they're saying is like, traditional systems, like you create this user vector with different location, time of the day, and contextual factors, and then somehow you match with an item vector. But here users can kind of supply what they want through text and all, you know, like, so they can create this recommendation system. And but if we dig deep into their own retrieval system, that's what they call, like, which retrieves items, it also will definitely convert this context into vectors, right? They have to.
Mhm.
So then they say, yes, we have, why we have two stage retrieval, two stage recommendation thing. It is for retrieving the candidates and then ranking them. So it is like a normal thing. Yeah, so then they talk about retrieval. This is like the hardest part, I would say. So the retrieval, the purpose of the retrieval phase is to take the full corpus, which for some domains such as videos or URLs may contain hundreds or millions of items, right? And based on the context, select small number of candidate items like top 100 given some kind of a user context. And then they have this downstreaming ranker. So they say the key challenge is here to kind of if we like, it is not easy to like merge everything into one system. That's what they say. It's not, could not be trackable, and it would not be computationally feasible. And I also personally think you don't need to do it, because you can always do it offline. So in figure 5 we illustrate a general conceptual framework for retrieval in our problem setting. An LLM processes the session context and generate a request either implicitly through a model activation layer or explicitly through a language interface input. So they are like, you can get an embedding directly from the LLM as well to match it, or you kind of can use the text as a query, like do a Google search or something, to a system that you already have. So yeah, so this is pretty much what happens, so yeah, now with this it's easy to understand, right? The language model here, so it doesn't do anything. All it does is it will input comes and it will give some output, and there will be different turns, and in some turns there will be like keywords. Once you have keywords, they will like turn on their API and kind of see the recommendation engine is there, and they will kind of
what does
get
recommendation engine look like is my
yeah so it's pretty much like a normal recommendation engine, like, because this could be text. If this is a text, so they should have a system inside here, like off the shelf system that will encode text into an embedding, and then get the similarity machine, like approximate nearest numbers. And yeah, so this is pretty much it. There are different ways of retrieval system, like recommendation system here, engine. So dual encoder models. So dual encoder means you have two encoders that will encode users and items into embeddings, and basically what they're saying is, for that you can directly take the embedding of the user context from the LLM. See, request type is direct, you are sending embeddings, and then you can use k nearest neighbors, or scan is a library from Google to do this approximate nearest neighbor search. So
is it better than faces and all the other?
That's I don't know, like I use now something called NMS, but I mean there's not much of a difference. I don't know when it comes to billion scale, but I do quite a huge ones, but I don't know. So then the next one is direct LLM search. So direct LLM search is more like your LLM, the request is more of a text, it's like directly some kind of text, some kind of context.
You ask ChatGPT for recommendations, and then somehow get some keywords from that.
Keywords, and you send that keywords from the request, and then our engine does some fuzzy lookup, like text to text matching. Oh, for these keywords,
this was all inside recommendation engine, right?
No. This is more like this is the request type. See what kind of request we get,
Yeah. Okay, you can do multiple. Okay.
Yeah, then concept based search. I think this is also like bunch of concepts, like we can create concepts based on these YouTube videos. Yes, LLM decides, but then we always use this different retrieval mechanisms, so we might not get into hallucinations and all, because we can't, right? We can't squash all the model.
So the recommendation engine needs to support all those four.
Yes, because I mean, because this model doesn't know anything about your item stack or something. So basically, again, to highlight. So how they use this language model is as an interface, which I really like. I think this is the way to go when it comes to create applications,
But
not
I
just
mean, you do
blindly
have to
use.
fine tune the language model, or like prompt it so that it picks the
Yes.
right approach.
Yeah, I would say like, yeah, basically, yeah, because to keep a conversation, to extract more user context features and all, it would be better to fine tune, or like you need to prompt it in a proper way. Definitely, yes. Then this is like search API lookup. This is YouTube,
YouTube.
right? This is Google. So
Yeah.
basically, this is search. This is, so in the paper they say this is what they have used. Yeah, so that's pretty much it. And I highlighted this stuff, like, but I will share the link. But this is pretty much what we discussed now. And yeah, like, so search API is what they have, YouTube search. And finally we'll go through this ranking and explanations. So after candidate items have been retrieved, a ranker decides which of them will be included in the recommendation slate, and in one order. In what order?
In what order? Yeah.
Yes.
That seems straightforward.
Yes. Unlike the retrieval module, the ranking module does not need to perform trackable search over large corpus, and therefore less constrained in the type
Tractable.
of computation. Tractable. So basically they are saying, like, when it comes to re-rank, you don't need to use this embedding, so like fussy ways to kind of extract text or use some kind of a given API like YouTube.
It's like a two-step ranking, right? Because similarity matching, you can get 100 similar ones, and then you rank them afterwards. That's
yes,
better than trying to get the ranking directly from the recommendations.
Yeah. I mean,
From
that's
the
that's a way to do, right? I mean, I'm pretty sure these Amazon and these kind of people, they conduct this kind of stuff. So basically,
because the similarity matching gives a rank as well, right? But
yes, I mean, you can get, because
that, right?
what are the top 100? No, what they're saying is they are taking top 100.
Yeah.
Then they further kind of reduce
Refine
the
it.
search, further refine it. Yes.
So maybe the 90th one is quite relevant. In the end, it might be rank first, even
yes,
though in the similarity rank it'll be quite low. But
because I guess, like, because maybe they can create more conversations on with those
more
recommended
specific,
items. Yes,
yeah.
because then user can kind of interact with them, right, directly. Now it's in the text space, and it's in the language model space.
Yeah, that's quite
Yes. Yeah, that's pretty good. Like, so imagine you have a bunch of text, and you can create a prompt or something, like, okay, user has like this, and now we have like 10 or 100 new products. These are titles. What do you think? Like, why user would like these things? What do you think? Those kind of stuff you can infer, right?
Mm-hmm.
Because now it's more trackable. Yeah. Then they say, like, when it comes to context and all, like, metadata they use about this, product metadata they can use, because it's a text. And also LLM jointly generates a score and a natural language explanation for the score. So these scores implicitly induce a ranking of the item. The first step is to create a text summarization of the item that fits into the context window of LLM based on metadata associated with the item. Yeah, in the case of YouTube recommend, and this metadata consists of information such as a title, knowledge graph entity associated with the videos, developer description. They're saying, like, how they have, like, kind of process the metadata of the already retrieved items. In the future, this would be also expect a large multimodal model to directly process raw videos. A joint LLM ranking and explanation module. The conversation is used as a context for the user's preferences, and the video metadata is used as the context for the item. So you have some item. The LLM takes in summaries of item side and the context side to produce scores, produce scores for the items and explanation for the score. It's like it's again a text thing,
LLM output.
good. Yeah, good
Yeah.
fit.
Yeah.
It's a good fit. Yeah, it's pretty much.
Okay. Yeah. I mean, if you do that, then I don't know how they rank good and
Yeah,
great.
I saw like they have several classes for that. I mean, even sentiment analysis they kind of do this, so
So
basically
great is
good,
better than
bad.
good,
Yeah, I think it's more
and
like
excellent is
how
better
you.
than great, or what?
Yeah, it's more like how you train, how you fine
Yeah.
tune this kind
Okay.
of prompts.
Yeah.
But idea is like you can see context, you summarize this, you
Yeah.
summarize the item. So basically, maybe there are several item metadatas, maybe,
Yeah. Yeah.
or like maybe they put a single item and single context or several because it's an
I think
LLM.
it's one at a time, right? Because each one will need an explanation and a fit score.
Yeah, maybe. Yeah, I mean I don't know, but seeing GPT-4, you can maybe like put
It's
everything
just
and
one
say like
batch. It's a one
yeah,
batch.
one batch. Yeah, this video has clips of cute pets, and yeah, that's pretty much it. So um, last
That's good.
thing, so one of the key advantage of CRS is the ability of the user to articulate their preferences over the course of a season, over the course of a session, so that the system can assist them without necessarily needing any prior background information. Despite this, the personalized experience can be improved if the system has built up a profile of the user beforehand. So it's like a Facebook profile. You can say what you like and what are your preferences and all. So you get this idea, right? So what they're saying is they can easily kind of track user profiles with text and use this information with Rec LLM, so it will give better results.
Mhm.
Yeah, that's that. And uh, yeah, I also like this part. An important open research question is how to structure a user profile in terms of natural language. Currently, in Rec LLM, we represent user by a set of salient facts we have extracted from prior session. I do not like listening. They also tell about how they have like plugged this API code. Currently, at each turn of Rec LLM retrieves a single fact from the user profile by embeddings. So do you understand like what they're saying is there are like sophisticated retrieval mechanisms, like
Mhm.
if they want to go to if they want to get more user data, more user related data, they can always like kind of look into their database, and which is already vectorized, kind of get this cosine similarity, same as that, like sentence transformers, I
Mhm.
mean simply. But that's the idea. So you kind of can do a lot of stuff. And then this final one is like, I kind of like this idea, simulation and large scale tuning. So what they're saying is this could be done by collecting a high quality data set and doing transfer learning, or but they're saying is it's not that easy sometimes, like like because in a large scale setting we don't know how many examples we might need, and also they're like, why not use a simulation kind of. So basically again, like using an LLM to generate training conversations, and so yeah, like the idea is like I am 12 year. So the idea is like in this user simulation, you can see like you have some kind of a variable that can define the user. I am 12 years old boy who enjoys painting and video games, right? And
Yeah.
then now in the first utterance, hi, I'm looking to find YouTube videos about Mario Kart and 8 Deluxe. What is that? What is this thing? I don't
Mario
know.
Kart 8
I
Deluxe
don't.
is a game, I think.
Mario Kart 8
That's
Deluxe.
one entity.
Yeah. So then like this is another LLM or same LLM. Sure, here are videos showing gameplay on Mario. So basically an example of session based control. A single variable user profile is used to condition the user simulator. So the idea is we'll go through, they have this single this variable. You can see this entire session is based on this variable,
Hmm.
so it's like using then an example of turn level control. A series of variables are used to condition the user simulator at each turn. So this is like the preference. Hi, I'm looking to find YouTube videos about Mario Kart Deluxe. So, and sure, here are videos showing gameplay and all. And this is like chit chat. Thanks, I love this game. I've been playing. So you can see there's no real intent here, right?
Hmm.
So maybe like you are prompting to generate something like that. And also this part also comes from uh, something like ChatGPT. Actually, they have used Lambda for all these experiments, and like that's so. Then they have some other methods as well, like how to make this how to make this simulator really good, like how to make this diverse. But like I I don't know like whether we need this part in a commercial application, because this is YouTube. Still, this is a proof of concept application. I don't know how accurate this would be, this kind of data, but still I think LLMs can be used as an interface for these kind of problems, uh, like in a perfect way. So yeah. mm, that's pretty much it in this paper actually. So basically finally they show like some of the system design architectures. That's pretty much it. So as the closing thing of this paper, what do you think, like what do you think of this application? Because this is still a proof
Yeah.
of concept thing, like
Yeah,
even
but it's a bunch of LLMs. I think like the future will be like architectures like this, which are a bunch of LLMs talking to each other and a bunch of a
yeah
complicated system, not just like one LLM. It'll
yeah
probably involve a system of multiple.
yes, and another important thing is retrieval will play a huge role, right? Like
Yeah,
literally,
yeah.
because it's all about using parametric knowledge plus this outside knowledge. Yeah, it is pretty interesting, and yeah,
And I think
let's see.
the two-step filtering is also a good idea. I don't know if it's
What do you mean by
done
two-step filtering?
because you
The
do the
ranking.
first similarity ranking and then after
Yeah.
do another ranking.
Yeah, I mean there are different normal ranking models, like they can pick given some items.
Yeah.
Again, like what
I
are
mean, those
but
are like small engineering things that
yes,
are helpful for actual
exactly.
applications.
Yes. All right then. So yeah, let's call it a day,
Yep.
and yeah, let's call it a day, and we'll come up with another episode soon. And thanks a lot, Riv. And I
All good.
hope you enjoyed this as well. And yeah, let's meet
Yep.
again. Bye bye.
Yep.
See you.
Sounds good.
Take
See ya.
care.